Welcome to online video training for the CTI Workbench Integrated Development Environment. This is Course 1, Part 2. Basic Concepts of Workbench. Running time 12 minutes. Now, let's get started. The workspace, also called project list, contains a single project, or multiple projects that can be worked on simultaneously. The projects can be all for the same target, or can be for different targets. Data can be exchanged between projects running on different targets using variable binding. A target device is a physical device, such as a 2500p-ACP1 module, or 2500p-C2000 series CPU. Each project has a target device associated with it. The IP address of the target device is specified in the project settings dialog. A project is a collection of programs, variables, I/O configurations, external communications configurations, and data exchange configurations, developed to run on a specific target device. A project can also include SPI lists, charts, soft scopes, trends, graphics, graphical displays, and other debugging tool configurations. Within a project, the project settings dialog is used to specify details of the project environment. The communication parameters, IP address, for the target device. And runtime environment settings like cycle time, online change enable disable, and project compile options. The startup project is the project associated with the toolbar icons, and the project used when entering online or simulation modes. The startup project name is displayed in bold text. When more than one project is contained in the workspace window, you can designate another project as the startup project by right-clicking on the name and selecting the Set as Startup Project option from the pop-up menu. Program Organization Units, POUs, are program types created by the user. POUs include programs, exception programs, functions and subprograms, function blocks and user-defined function blocks, UDFBs, and SFC child programs. Programs are the highest level POUs, called directly by the runtime as part of the execution cycle. An application must have at least one program, and can have a maximum of 32,767. If more than one program exists, they are executed according to the sequence defined in the cycle configuration menu. Programs are made up of logic instructions, expressions, and calls to other subprograms, functions, function blocks, and UDFBs. They can include local variables as well as global variables. Each time a program is triggered by the runtime, it executes from start to finish. Programs can be developed using any available language, and programs written in different languages can exist in the same application. Exception programs allow the user to create logic to perform special processing and error handling. The exception program, startup, runs once, before the first execution cycle when the application starts. The exception program, shutdown, runs once, after the last execution cycle when the application stops. The exception program, divide by zero, runs when division by zero is detected. And the program, bad array index, runs when an invalid array index position is used. A function calculates a result based only on the input values. An example is the addition function, which adds together all the inputs and stores the result in the output. A function allows multiple inputs but only one output parameter and no internal data. Functions are global in scope and can be called from any POU. Workbench includes both IEC standard functions, to do math, string, array, and many other operations, and CTI functions, to do operations specific to the product. The function shown here has 4 inputs and 1 output. A subprogram can be thought of as a user-defined function, with multiple outputs. A subprogram may include up to 256 input and 256 output parameters, and can be developed using FBD, ladder, structured text, or IL language. Local variables may be declared and used in the embedded logic code, that can include calls to any other function, function block, and/or UDFB, except SFC child programs. Since the subprogram executes like a function, it is not instantiated. This means the same set of internal variables are used for all occurrences within the application. function blocks contain both code and private data, inputs, outputs, and local variables. When called, the logic reads the input parameters and performs the specified operation on the private data. The runtime includes both IEC standard and CTI function blocks. These function blocks contain internal programming, but it is not visible to the user. The IEC 61131 model uses the data structure construct as a template, or data type, for the internal data. An example of a function block is a timer block. To use a function block, a unique variable having that data type must be declared for each occurrence of the function block in the application. This creates an instance of the function block and its private variables. The user-defined function block, UDFB, is a user-developed program unit that is operationally equivalent to a standard function block. However, the programming is done by the user and can be viewed and edited. There are no restrictions in the development and usage of UDFBs. The logic can be constructed in any available language. A UDFB can be called from any other POU, and its logic can call any function, function block, and/or other UDFB. A maximum of 256 input and 256 output parameters are supported. Instantiation is a technical programming term which means the creation of an instance of an object. Each instance created by instantiation is unique and has memory between scans. A good way to think of instantiation is to consider the use of a timer block versus a simple math block. A math block, like addition, has inputs and only one output. The output is always the same for any given set of inputs. There is no memory within the block. Each time it is used, it produces an output. A timer block, on the other hand, has memory inside which retains the current time between calls to the timer. And each timer used in the program is unique, because it maintains its own internal timing. In CTI Workbench, programs, function blocks, and UDFBs are instantiated. Functions and subprograms are not instantiated. Variables. All data elements are addressed by name, as opposed to the direct, or absolute, addressing method used in the Siemens 505 and CTI 2500 series controllers. A data type must be assigned, i.e. Boolean, integer, or real. The user can create a custom type that combines various data types into a complex unit, known as a structure. Arrays of variables of all data types can be created, so that common elements can be grouped together. 1, 2, and 3-dimensional arrays may be used. Variable naming. The first character must be a letter, or an underscore. Following characters must be letters, digits, or underscores. You cannot enter 2 consecutive underscore characters. Names are case insensitive. Maximum length is 255 characters. Variable classes. Global variables are known to all programs in the project. A local variable is known only to the POU where it resides. Retain variables are non-volatile global variables, used to restore critical values to previously stored states. Retain variable storage is unlimited in 2500C 2000 series processors, and limited to 11.5 KB in the 2500P-ACP1. Workbench supports 20 different standard data types, ranging from simple booleans and integers, to reals, and long words of 64 bits length. Arrays. A dimension can be specified to create a variable array. Up to 3 dimensions are allowed. Enter dimensions separated by commas. The first element is always element 0. You can also declare arrays of function block instances or structures. Support for data structures allows creation of a macro variable, consisting of individual variables which can each have different types. Each variable of a structure may have dimensions, and/or may be another structure. For example, we can define a structure, motor, which includes on-off, Boolean, direction, Boolean, speed, integer, temperature, integer, and current, integer. Access to the data is done using the following syntax. Motor1.onOff, or motor1.temperature. The definition and use of data structures is covered in Class 2. Enumerated data types are defined as a list of possible values, common status, OK, fail, busy. Up to 256 enumerated values are possible. To use an enumerated type in an assignment, Include the data type, the pound character, and the value. Definition and use of enumerated data types is covered in Class 2. Bit fields data types are used with integers, and allow you to give names to bits of the integer. And then use the bit names like a structure. Drive status.1 indicates bit 1 of the variable drive status. Using constants in expressions. For booleans, the reserved words true and false are used. For integers, prefix the value with the data type name and pound sign. For reals, you must include the data type, followed by the pound sign, and the value, which must include the dot and any fractional part. Scientific notation is supported. Using constants in time expressions. Time constant expressions represent duration that must be less than 24 hours. The value must be prefixed with t-pound, or time pound. The value is expressed as hours, minutes, seconds, and milliseconds. The order of units must be respected. The Workbench execution model is a scan cycle which includes 4 steps. First, inputs are updated using data from communications and I/O performed during the previous scan. Next, outputs are sent by generating communications and I/O messages which were triggered during the previous cycle. Then, all programs are executed according to the project cycle settings. The scan watchdog is active during this portion of the scan. If a fixed cycle time is specified, the system then sits in an idle mode until the time expires. Then the scan begins again. Communications in Workbench. All I/O communications and external device communications are configured in the field bus editor. Communications between projects is configured in the variable binding editor, which is covered in Class 2. This completes Course 1, Part 2, Basic Concepts of Workbench.